This video will show you how to use R command to run logistic regression for modeling binary response variable. In the example I use, the response variable is the disease status and it's binary, and I have 4 explanatory variables. Age is quantitative and the other 3 variables are categorical variables. In actual modeling, the response variable should be binary and takes on 2 values, 1 or 0. 1 is the category of interest. In this case is yes, have the disease. And to include categorical explanatory variable in the model, we have to set up indicator variables for them. So for saving account, we can set up an indicator variable for indicating whether a person had saving account or not. So 1 means yes and 0 means no. In this case, no, 0 will be the base class for saving account. For socioeconomic status, there are 3 categories. We can set up 2 indicator variables. The upper indicator variable takes on 1 when it indicates an upper class and 0 indicate not upper class. And we can have another indicator variable middle class, and when it's taken 1 it indicates middle class and 0 not middle class. And of course when both of these takes on 0, that's indicating the lower class, and the lower class is the base class for this categorical variable. And for sector variable, we can set up indicator variable for indicating sector 1. And 0 will be the base class, which means the sector 2. Of course, when we really run the regression model, the R commander will actually automatically set up indicator variables as long as we have these categorical variables set up as factor variables. Now this is the data that I will use for running a regression. And the socioeconomic status, sector variable, and disease variables, they're all categorical and the actual value were characters. The saving account itself is numeric, it takes on 1 or 0. Now, although R commander can set up indicator variables automatically for us for these categorical factor variables, but we still like to have good control of how the variable was set up and maybe able to do some reordering to make the setup the way we want. To do that, we can click on Data, Manage Variables in Active Data Set, and choose Reorder Factor Levels. And this allows us to order these different levels in a factor variable. I'm going to start with the disease variable. So I click on disease and click OK. And yes, override the variable. In this window dialog box, we reordering level. 1 is assigned to without disease and 2 is assigned to with disease. And this is really what we want. Now, when you have 2 categories, the R commander will assign just 1 indicator variable for it, and it will assign value 1 for a higher order number and 0 for lower order number. So the indicator takes on value 1 with disease and takes on value 0 when it's without disease. So I click OK. This is good. And how about socioeconomic status? So we click on Data again, Manage Variable in Actual Data Set, Reorder Factor Level. I'm going to click on socioeconomic status variable and click OK. And yes, override variable. Now in this case, upper class is lower order number and lower class is higher order number. Now if you want to do your analysis with lower class as a base class, then you want to change your order. Make the lower class 1 and upper class 3. So the lower class would be base class, and the R commander will set up 2 indicator variables, 1 for indicating upper class and 1 for indicating middle class. So I'm going to click OK. And the last variable to set up, we click through this again, reorder factor level, and that was a factor variable. So select factor variable and click OK. Yes, override variable. Now if you want to indicate a variable for indicate sector 1, you should make that 2 and make sector 2 1, so that sector 2 be the base category. And so remember, you just put order 1 for any time you want that category to be your base category, and then click OK. And I'm ready to run the logistic regression. The savings account is already an indicator variable, so we don't have to do anything about it. 1 indicating had saving account, and 0 indicating didn't have saving account. Of course, one of the goals for this regression modeling is for modeling the odds of getting disease using the 4 predictor variables. Of course, socioeconomic status is split into 2 indicator variables. And we can convert this model into a model for probability of getting disease using these 4 predictors. Now, to run the logistic regression, we click on Statistics, Fit Model, and select Generalized Linear Model. And since the logistic regression, so we select binomial family, and the link function will be logic. And we're going to pick the disease status as the response variable, so we put it in the response variable box. I'm going to specify the model. I'm going to use H variable plus saving account plus socioeconomic status and plus sector variable. So I have them all included in the model. And I'm going to click OK. And the R commander will put the outcome in the output window. You see the summary statistic about residual and also the coefficient estimate for all these different parameters. When you look at the p-value, you realize that H variable is a significant factor since at a p-value less than 0.05, and also the sector variable is significant, and the socioeconomic status, they are not significant. If you look at the coefficient estimate for H variable, it's a positive number. That means that H has a positive correlation with the disease. As H increases, increase the chance of having disease. And saving account is positive too, however, it's insignificant. And sector has a negative number. That means if you move from sector 2 to sector 1, the base class, to sector 1, it decreases the chance of getting disease. And later on we're going to look at the odds ratio to help us to better interpret these numbers. The same for these socioeconomic status since they're indicator variable. Logistic regression analysis can produce a very useful statistic for interpreting the results of the analysis. That is the odds ratio. The odds ratio is the exponential function of the estimated coefficient. So just now we run the model and save it in general linear model.1, and coefficient coef function can bring out the coefficient estimate, and then exponential function of that just give us the odds ratio. So if you run this script, you will get the odds ratio statistic. Here the odds ratio for H is 1.02. That means increasing H will increase the odds of getting disease. For savings account, 1.062. Again, that indicates that if you move from no saving to having saving, that is for indicator variable takes on 0 to 1, that increases the chance of getting disease. For socioeconomic status, this odds ratio is the odds of getting disease for the middle class versus the base class, which is the lower class. And this number is less than 1. That means the middle class has less odds of getting disease than the lower class. And the upper class odds ratio is 0.75, again is less than 1. That means the odds of getting disease for upper class is less than the odds of getting disease for lower class. In sector variable, you have a 0.29. That is again less than 1. That means if you live in sector 1, your odds of getting disease is less than sector 2. Of course, in our output, the savings and the socioeconomic status, they are not significant factors. So the odds ratio doesn't have much meaning. However, for sector variable, if you take reciprocal of this, it's about like 3.4. So that also says that, well, if you live in sector 2, your odds of getting disease is more than 3 times the odds of living in sector 1 to get disease. To get confidence interval estimate for odds ratio, I can apply this exponential function to the conf_int function on the model. The conf_int function gives us the confidence interval estimate for the parameter, the coefficient, and exponential function applied to it give us the odds ratio. So I highlight this and then click submit. I'll get the 95% confidence interval estimate for odds ratio. This will be the lower bound, this will be upper bound.